Day 4 for scientific notation. We're writing and comparing numbers in scientific notation. So our example problem is to write 0.0000408306 in scientific notation. You know you need a number between 1 and 9, and the quickest way to get that is to just put a decimal after your 4. So you got 4.08306, and to get back, or to get from this number to our new number, we go from a smaller to a larger number, which means in order to get back from this big to the large or big to the small, we need to go to the left. And then to get back from our 4.08306, you moved 1, 2, 3, 4, 5 times. So it should be 4.08306 times 10 to the negative fifth power. Again, so you're seeing our new number between 1 and 9 is larger than our original. And since it's larger, that means in order to get back to our original, we have to move our decimal point to the left. Okay, that's why we're doing that. That's why our exponent is negative. All right, and let's go ahead and move on to here. So Earth is about, I'm not even going to attempt to say that number. Write this number in scientific notation. So again, you need to know that to go from standard form to scientific notation, you need to figure out, first off, it needs to be a product of two factors. One of them needs to be a number between 1 and 9, and the other needs to be a power of 10. Okay, so now that you have that, our power of 10, we can figure out as soon as we figure out what our number is between 1 and 9. So we look and we just kind of leave those extra zeros alone. And we say, well, what's the number between 1 and 9? And we have to address all of our excess digits that aren't zeros consecutively. So we have 5, 9, 7, 4. And if we put a 0 between the 7 and the 4, that's a number way bigger than 9. So that cannot be it. If we put our decimal here, we'd have 59.74, which still is not between 1 and 9. The only place that it could go logically is between 5 and 9, because 5.974 is between 1 and 9. So you have to understand why we're placing our decimal there. And then we can find our power of 10 here. So we're going from our new number being much smaller than our original number. So this new number is smaller than our original number, which means we're going from a smaller number to a bigger number to get back from scientific notation to a standard form. So in order to do that, to go from a smaller number to a bigger number, we need our exponent to be positive. And we would have to move our decimal point 1, 2, 3, at least 3 so far, plus all of our zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 21. All right, so then we're moving it 24 times. So and you can just easily count that: 3, 6, 9, 12, 14, 16, 18. Oh, I think I just did that super wrong. I did 3, 6, 9, 12, 14. I said 3, 6, 9, 12, 15, 18, 21, and it is 24. Okay, I'm not crazy. To the 24th power. And I don't even know how I changed the color that quick, but there we go. All right, so you have your solution of 5.974 times 10 to the 24th power is our solution. Done. All right, moving on to number 20. Use the information in the table to solve the problem. We've got the orbiting bodies of Mercury, Mars, Neptune, and Pluto, and the approximate distance from the sun. Remember, the larger the distance, the farther away it is. So let's put that on our paper so we don't forget that. Larger the number, the farther the distance. Okay, and we're gonna go ahead and move on. So write each distance in scientific notation. Again, you need a number that's between 1 and 0. So you should have a whole number with a decimal and the rest of the digits. All right, so we can have for Mercury 3.63 times 10 to the something, and we'll just come back and add them all up after this. Do the same thing for Mars and Neptune and of course Pluto. All right, so for Mercury, we need to move our decimal 1, 2, 3, 4, 5, 6, 7 times. And again, we know our digits or our exponents should all be positive because we're going from a new smaller number to a really large number for the approximate distance from the sun. All right, so Mars, we go from 1.42 to 142 million. So go ahead and add those decimal places up. So 1, 2, 3, 4, 5, 6, 7, 8 times. Neptune, same thing, 9 times. And then Pluto, 9 as well. All right, so that means like Neptune and Pluto are actually very close because they have the same exponent. All right, so our question, Neptune is about how many times as far from the sun as Mars is from the sun. So we did this on a previous day of this lesson. We need to have the farther distance compared to the closer distance. Farther goes on top of closer. So the one that's farther is Neptune, of course. And our Neptune, it should be Neptune over Mars. Neptune's scientific notation, written in scientific notation, distance is 2.8 times 10 to the 9th power. And Mars is 1.42 times 10 to the 8th. And it said about how many. So we can just approximate even further the 1.42 to just 1.4 because Neptune also just has the 1 digit behind the decimal place. So we can do the same thing for Mars to make it a little bit easier for ourselves. So we'll go ahead and we'll break apart our fraction into the numbers between 1 and 10, or I'm sorry, between 1 and 9 and our powers of 10. So we've got 2.8 over 1.4 times 10 to the 9th over 10 to the 8th. And we just simplify. 2.8 divided by 1.4 is 2. And then 10 to the 9th divided by 10 to the 8th is just 10. So about how many times as far is 10 to the first. So it's about 2 times 10, which is about 20 times as far. And that's our answer here. All right, and we've got our answer for number 20. And finally, for day 4, we move on to number 21, which is equivalent to 8.03 times 10 to the negative 8th power. So we need to move on. What's very important here is that we see that our exponent is negative, which means we have our starting number between 1 and 9. And we're actually going to move our decimal point 8 places, of course, to the left. Let's do that. 3, 4, 5, 6, 7, 8. You have your decimal and all of these zeros. So we actually will have 7 zeros in front of our 8. And that is C. Eva chose D. And what's so important with that is if we start off with our, of course, number between 1 and 9 in our scientific notation, in scientific notation, and you go the opposite way. If you go 8 places to the right, 1, 2, 3, 4, 5, 6, 7, 8, you'll end up with what Eva did. Okay, so she kind of didn't know what the negative 8 meant. So she got that because Eva moved her decimal place or her decimal point. 8 places to the right. She shouldn't have done that because a negative 8 as an exponent means that we need to move the decimal 8 places to the left. But that was her mistake. And that is it for day 4.